in gas phase. Let about these examples. So what type of rearrangement we would expect for these molecules in gas phase? So we have given H nu in gas phase. As a result, first we will have this triradical species, double bond O. Let's just consider this is the diradical species. Then first this diradical will make a bond. If I ask why this not, because they partly get stabilized by through this C double bond O. That's why they will not undergo bond formations. So yeah, so this is the new triradicals. Now what happens? Look, now this undergo bond formation here. This is double bond O. Sorry. So I have drawn some different structure. Then what will happen? So after this kind of bond cleavage, so it's a five-member molecules now. It's a five-member molecules. Now here we have one dots, and these dots, so as will be there is a bond, and we have this dot here, and here we have another dots. And they will make a bond. Double bond. So simply, if this is given, what is the rearranged product after treatment with light in gas phase? We will do this. Why I spent a lot of time on this chapter? That I repeatedly telling. This is such a chapter. This is the most coding chapter. Next, this is chapter that is non-taught in BSc. So the people, those are doing the questions for CS and NET, they will have much more expectation that they want to ask much more chapter from this. That's why this is very much coding chapter. Let us discuss this example. So what will happen for these molecules in gas phase? Let us say this is the examples. We have CCl3 and methyl. So we have treated these molecules in presence of light in gas phase, and say in some another way we have treated this molecule with H nu, but in presence of a H donor solvent. In presence of H donor solvent. Then we will have a look what will happen in this different states. Okay, so know that I'm now not showing the mechanism. Now you are very much aware that if this happens, that is going to be this kind of product in gas phase, double bond O, and here we'll have a bond between PCl3 and methyl group. That is in gas phase. But we'll have a look what will happen here. That is in presence of H donor solvent. So that is the main vital topic. So CCl3. Then what is the fate of these molecules? H nu. You see, in gas phase, we have found that the radical that generate here in the double bond system, not in the C double bond O, they generate through the C double bond C. That is the basic difference. And because in gas phase, you know that any kind of cation, this is not the direct expression here, but I am trying to give an explanation, so give a flavor of these things. See, any kind of cationic or anionic stabilization do not happen in gas phase. So if something charged particle generated in gas phase, that is not going to be good one. That's why they do not harm the anionic means carbonyl systems. Look, as this is in the presence of solvent donor, H donor, that's why here is a O dot and C dot. Something after some step, if O dot become negative or whatever something else, that has some quite stabilization from the solution part. That's why these kind of things happens here. You should remember this. Okay. So what do not happen in gas phase. In gas phase, N2 pi star do not happen. Remember that. N2 pi star normally do not happen. Normally do not happen. Okay. Now we have these systems CCl3. Then what will happen? Then ultimately this have a delocalized structure here. You will have these things O dot new bond here, new dot CCl3 and CH3. So this kind of things will happen. However, as it's a H donor solvent, so here are the things. H donor, we are doing this in H donor solvent. That is that a solvent that can donate a H dot to the center. That's the most important or highlighted part. So what we are going to have? We are going to have these things. OH plus CH3 plus in the system we will have CCl3 dot as is in the presence of H donor solvent, it is going to produce CH CCl3. Another way that to CCl3 dot can dimerize to produce CCl3 CCl3. The thing that we should keep in mind, it is in gas phase. In gas phase, we are if we have diene on, first step is going to be the radical in the systems of C double bond C. But it is some different solvent that is the N2 pi star. That is going to be factor. This is the most vital. It comes from true and which is true, which and false these forms, or you can. So this is a very very important discussions. Now I'll show you different kind of example in gas phase. Let's say I have given this problem has been given. So what will happen? Uh, this is the molecules. Let's here a strange ring double bond psychopropyl ring has been introduced. Then the question is asked: H nu in presence of a in presence of H donor solvent. Later I will give examples. The examples of H donor solvent. Then we know as this is in the presence of H donor solvent, so our first step is the breaking of CO bond in homolytic way. Then second step we will have this kind of delocalizations CO dot sorry yeah here the things comes. Now this bond will delocalize as this as it's a strength remembering as a result, but the things is going to be this and this OH as H dot will be supplied from solvent. Let's write this in the safety dot. Then again, if H dot is supplied from the solvent, H dot from solvent, then that is going to make a bond there, and we will have CH2 CH3 OH. So here I will put the examples of solvent. Which kind of solvent? Ether can be a good solvent for that. So if something, let's say C2H5O, C2H5O, that can be a H dot donor solvent. H dot donor solvent. So if instead it has been given, so what will be the product in presence of H nu and C2H5 whole to O, it is the same thing. OH, CH2, CH3. Another thing, so if CH3, CH2, O, this is the diethyl ether. If it's a donate, let's say this hydride, then it is going to convert into CH3, CH dot O, CH2, CH3 dot. Now this dot can dimerize. Means we'll have product like this CH3, CH, CH3, O, O, ET, I put ET. And these dot also can be added here. So from this we'll have the product, these things. Let's I write it different way. That is OH. Now here CH3, CH2. Now CH dot coming into picture. Here CH3 and here O, CH2, CH3. And normally we don't need this product. We need only this. Okay. Then I'll show you an example.